Okay, so part two of our inequalities, or of our absolute values, is going to focus on inequalities. They are a little bit more nuanced than equations. You know, it's not just going to have like um, one of the just solutions and you're going to be done with it. You're going to have to figure out a range of values that work for these, and a lot of times it's beneficial to look at a graph. So I'm gonna go right ahead and just kind of focus on, well, what does this look like graphically? Okay, so when I'm talking about the absolute value of 3x minus 12, well, I can think about, I mean, you can guess and check, you know, if I do absolute value, you know, what is a number, you know, if I plug in 5, does that give me a number greater than or equal to 6? No, 3 doesn't work. So maybe if I plug in 6, well, that technically works. 6 works, you know, so 6 gives me a number greater than or equal to 6, but, you know, there's lots of different numbers. I could do 7 and 8. And seemingly any number higher than that's going to get me a number greater than or equal to 6. But also, you know, let's think about going the other way. So 5 didn't work. What about 4? What about 3? 3. Okay, so notice it's going back up. If I put 2 in, that's going to give me 6 again. So it looks like, you know, 2, and if I put 1 in, I'm going to start creeping up above 6 as well. So absolute value inequalities, you know, actually have a range of values. And let's talk about what that looks like from the graph. So I want you to go to y1 and y2. And what we're going to do is we're going to find some cutoff points. So this is going to be y1. It's going to be y2. And this is a greater than or equal to. So this is greater than or equal to means above the graph. So I want to do absolute value of 3x minus 12. And I want to do 6. And I'm going to make sure my window is a standard window. So I'm going to go to Zoom Standard and just let that original 10 by 10, 20 by 20 window graph. So here's your 3x minus 12, and here is your 6. Now, what's going to happen is you're going to have 2 points of intersection on this graph. Second trace 5. Scroll over here, press enter 3 times. One of them is going to be 2. Second trace 5. Go over here, press enter 3 times. The other one's going to be 6. So those aren't my answer. It's not just x equals 2 and x equals 6. Okay, I'm looking for all values of x that fit this inequality, greater than or equal to 6. Look at a table, okay? Second graph will give you a table of values. Okay, 2 gives me a value greater than or equal to 6, and 1 does, and 0, and anything above here, my output's going to be greater than or equal to 6. Similarly, down here at 6, 7, 8, 9, 10, all those give me values that are greater than or equal to 6 as well. So we really have 2 points, okay? We have, I'll do the smallest number on the left side, so 2 and 6. 2 works, negative 3 works, 1 works, 0 works. Anything to the left of 2 works, okay? It gives me a number greater than or equal to 6. But also, anything above 6 works, 6, 7, 8, 9, 10. Look at those y values, they're all greater than or equal to 6. So I can also go this way. But numbers like 3, 4, 5, none of those work. I don't have any values, all right? So I can't plug in 3, 4, 5 and get an output that is greater than or equal to 6. So what does that inequality look like? How do we write that? Well, we first say x is less than or equal to 2. But then we can go to the right side. So we can say or x is greater than or equal to 6. X is less than or equal to 2, or x is greater than or equal to 6. And that's the solution. The graph is helpful to visualize what's going on. You can do 7 and 8 there. All those numbers give you greater than or equal to 6, but the solution is just a set of inequalities. Okay, so how about when it's the other way? So when it's less than. So first thing I want to do is I want to isolate the absolute value. So I am gonna I'm gonna add the 6 to both sides. I'm gonna say 2 absolute value 2x minus 3 is less than 8 plus 6, which is 14. Then I'm gonna divide 2. And I'm gonna say the absolute value of 2x minus 3 is less than 7. Okay, so once I get it to that point, I have my absolute value and my number isolated. I want to then see what kind of problems work for this. So I'm going to do absolute value. And again, we're going to do y1 and y2. y1, y2. This is always a good visual to kind of help what numbers make up, will give you numbers that are 7 or more. So I'm going to do 2x minus 3 in the absolute value. I'm going to do 7 in the y2. I want to look at a graph, see if I can find a point of intersection. And it looks like we can see it cross in 2 spots. So once I get that to draw, I'm going to do second trace 5. And let me sketch this graph out here. So second trace 5. Let's see. Enter, enter, enter. We have, looks like -2. And at 7, if I do second trace 5 and scroll to the right, get over here, press 3 enters, the other answer is going to be 5. 5 is going to also get you 7. But you know, it's not just x equals -2, x equals 5. It's all the numbers of x that give you numbers below 7. Okay, this is less than. So it's not. So first thing we want to do is we want to graph -2 and 5. But I'm going to keep those open circles and not closed circles because we're not including that. So open does not include. Closed includes. So if you think about what includes, does not include means that it's just less than, okay? Closed means that it'd be less than or equal to or greater than or equal to, or less, open could also be greater than. So as far as what makes this absolute value less than 7, let's look at our table, second graph. Okay, so we have a few options. At -2, it seems like anything above -2 gives me an output less than 7. So -1, 0, 1, 2, try to squeeze this, 3, 4. And then at 5 again, it's equal to, and above 5, it's greater than. So 2 and 5 don't work, but anything between them do. So how do we write this? Well, there's a couple different ways. We can say x is greater than -2. You can say and x is less than 5. And the reason I say and not or is because it's not going in separate directions, okay? And means it combines them when they're in between each other. So I don't know, you remember using the and when we were doing the compound inequalities. X is greater than -2 is the same thing as -2 is less than x, and x is less than 5. But if we switch that order, then really the simple way, the way that you need to write it is -2 is less than x is less than 5. So on a graph, it's basically all the x values between -2 and 5, not including those numbers. X is greater than -2, but less than 5. Okay, thank you for watching inequalities with the or going this way and the and. I should note that while I did not draw a graph here, when you look at your solutions, you got 2 and 6. This graph is above. So what you're looking, I guess visually on the graph, because we use the table to kind of get these numbers, but all the values of this graph that are above 6 are up to the left of 2 and to the right of 6. So the left of 2 and to the right of 6. So closed circle with the equal sign, open circle with not having the equal sign. Again, thanks for watching this.